ATP, or adenosine triphosphate, is often referred to as the currency of energy, or the energy store, adenosine, the energy store in biological systems. And what I want to do in this video is get a better appreciation of why that is. So adenosine triphosphate. So at first, this seems like a fairly complicated term, adenosine triphosphate, and even when we look at its molecular structure, it seems quite involved. But if we break it down into its constituent parts, it becomes a little bit more understandable, and we'll begin to appreciate how it is a store of energy in biological systems. So the first part is to break down this molecule between the part that is adenosine and the part that is the triphosphates, or the three phosphoryl groups. So the adenosine is this part of the molecule. Let me do it in that same color. So this part right over here is adenosine, and it's an adenine connected to a ribose right over there. So that's the adenosine part. And then you have three phosphoryl groups, and when they break off, they can turn into a phosphate. And so the triphosphate part, you have triphosphate, you have one phosphoryl group, two phosphoryl groups, and three phosphoryl groups. So one way that you can conceptualize this molecule, which will make it a little bit easier to understand how it's a store of energy in biological systems, is to represent this whole adenosine group. Let's just represent that as an A. Actually, let's make it that an AD. And then let's just show it bonded to the three phosphoryl groups. So, and I'll make those with a P and a circle around it. So you could do it like that. Or sometimes you'll see it actually depicted, instead of just drawing these straight horizontal lines, you'll see it depicted with essentially higher energy bonds. So you'll see something like that to show that these bonds have a lot of energy. But I'll just do it this way for the sake of this video. But these are high energy bonds. Now, what does that mean? What does that mean that these are high energy bonds? It means that the electrons in this bond are in a high energy state. And if somehow this bond could be broken, these electrons are going to go into a more comfortable state, into a lower energy state. And as they go from a higher energy state into a lower, more comfortable energy state, they are going to release energy. One way to think about it is if I'm about to jump, if I'm in a plane and I'm about to jump out, I'm at a high energy state. I have a high potential energy. I just have to do a little thing and I'm going to fall down. And as I fall down, I can release energy. There will be friction with the air, or eventually when I guess hit the ground, that will release energy. I could compress a spring, or I could move a turbine, or who knows what I could do. But then when I'm sitting on my couch, then I'm at a low energy state. I'm comfortable. It's not obvious, how I can go to a lower energy state. I guess I could fall asleep or something like that. And these metaphors break down at some point. But that's one way to think about what's going on here. The electrons in this bond, if you can give them just the right circumstances, they can come out of that bond and go into a lower energy state and release energy. So one way to think about it, you start with ATP, adenosine triphosphate, and one possibility, you put it in the presence of water, and then hydrolysis will take place. And what you're going to end up with is one of these things are going to be essentially, one of these phosphoryl groups are going to be popped off and turn into a phosphate molecule. And so you're going to have then adenosine. Since you don't have three phosphoryl groups anymore, you're only going to have two phosphoryl groups. You're going to have adenosine diphosphate, often known as ADP. Actually, let me write this down. This is ATP. This is ATP right over here. And this right over here is ADP, di for two phosphoryl groups, adenosine diphosphate. And then this one got plucked off. This one gets plucked off, or it pops off. And it's now bonded to the oxygen and one of the hydrogens from the water molecule. And then you could have another hydrogen proton. But the really important part of this I have not drawn yet. The really important part of it is the electrons in this bond right over here go into a lower energy state. They are going to release energy. So plus energy. So here, this side of the reaction, energy released. And this side of the reaction, you see energy stored. And so as you study biochemistry, you will see time and time again energy being used in order to go from ADP and a phosphate to ADP. So that stores the energy. You'll see that in things like photosynthesis, where you use light energy to eventually get to a point where this P is put back on, using energy, putting this P back onto the ADP to get ATP. And then you'll see when biological systems need to use energy, that they'll use the ATP, and they'll essentially hydrolysis will take place, and they'll release that energy. Sometimes that energy could be used just to generate heat, and sometimes it can be used to actually forward some other reaction, or change the conformation of a protein somehow. Whatever might be the case.
Thank you for watching this video. Don't forget to like the video.